This episode of Liquid Assets is sponsored by HASA, the leader in water treatment solutions. HASA delivers eco-friendly, reliable, and cost-effective water care and has been keeping communities safe, one drop at a time. They've been at it for more than 60 years, and you can learn more about HASA by visiting hasa.com. That's HASA, HASA.com.
I think we're in this arms race of technology and the problems that the technology creates. And it's really hard to say what individuals can do. Like, okay, we can recycle, try not to use plastics, don't use plastic straws. There's these little things, but I don't know, I'm left feeling like a little vacant, like I'm not able to impact things as well. We should be focusing on as individuals, and where I think we should be focusing on as corporations and entrepreneurs and technologists. I want to learn about what's going on to the best that I can, educate myself about the impact that the world around me is experiencing from humanity. But how can we create a hybrid of economic benefit and technological innovation and solve hard problems, right? If I were to ask you, Ravi, what can we do today to reduce ocean acidification? Have you ever thought about it, right?
Welcome to Liquid Assets. Liquid Assets is a podcast where we talk about the world of management, technology, and business, all as it looks at the world of water. I'm your host, Ravi Kurani, and today we have an awesome guest for you, Patrick Clasen. Patrick, how are you doing today?
Doing great, Ravi.
We have an awesome topic to discuss today. We're going to talk about everything from startups to coral reefs. You had some really interesting things we were talking about before we hit record. And I want to jump right into coral reefs. You were talking about coral reefs and copepods. Let's just kind of start back at zero again. And let's talk about why are coral reefs interesting? What do they matter? And what's really the issue that's happening here?
Well, so I started out at Ecotech Marine and as a college student, and my buddies and I got together and we had saltwater reef aquariums in our college apartment. So that kind of got me into the coral reef thing and knowing about what a coral is and why a coral is important. They're really beautiful animals, and keeping them in captivity is the hobby that has got us started. Through Ecotech, we were able to learn and find out about reef restoration through the Coral Reef Restoration, or the Coral Restoration Foundation down in Key Largo, Florida. And I don't know if you know, but the reefs around Florida are almost gone. They're about 98% dead, and they provide the barrier for a lot of the waves and the currents that come into land, right? They also provide habitats for the animals and fish that live in the ocean around Florida. And well, the Coral Restoration Foundation decided they're going to take matters into their own hands and try to help replant the coral on the reef. Molasses Reef was one of the spots where they were replanting. And back in 2012, we decided this sounds kind of fun. We could donate some money, and we got to go down and actually work with the Restoration Foundation and plant corals on the reef. Well, you might ask yourself, well, what does that look like? Well, they have these really interesting PVC structures that look like trees floating in the ocean. And they take fragments of coral. So a coral is kind of this animal that it's a symbiotic animal. It's zooxanthellae algae, and it's the coral animal, which is a respirating animal. And those things live in symbiosis and grow calcium carbonate skeleton. That's what creates the reef. Now, in order for them to propagate back in 2012, what they were doing was cutting up these little pieces of coral and using fishing line to hang them from this PVC tree underwater. And then once they got big enough, scuba diving out to plant these and basically epoxy 3 different genotypes, 3 different basically species or corals that could potentially crossbreed and plant them on the reef. So that's one method that people at the time were using to try to repopulate.
Really interesting. And just kind of a dumb question here. Why do we need coral? You mentioned in the beginning they were kind of a barrier to Florida in general, like for waves that were coming from the ocean. Do they serve any other purpose outside of just being a bit of a barrier on making sure that waves don't crash into land?
I mean, the coral reefs are the most diverse genetic ecosystem in the world. They put the Amazon jungle to shame. There's more animal density, biological density per square foot in a coral reef than anywhere else on the planet. And not to mention they're inherently gorgeous, beautiful, amazing places to visit, but they do provide the basis of many of the ecosystems that exist in the ocean. And so preserving them, on many fronts are important. Most recently, even DARPA has started working with a lot of these organizations in Florida to try to protect and replant the coral reefs because they serve a real financial purpose. Once you have erosion and beach erosion, it costs the US government probably billions of dollars. I don't know the exact figure, but big money. And so those different types of structures that provide barriers to hurricanes and storm surge and natural obstruction of those currents is really important, not to mention the biodiversity. So
really interesting. And you're kind of touching on something. I had a conversation on another episode just a week ago on how actually looking at drought in California and also on the East Coast. California is obviously very prone to drought and kind of has been historically. But one point that this gentleman made was Florida has these really big swings, right? Which are kind of actually difficult to manage from just a state level. Swings being that you have flooding on one side and then you have like extreme drought on the other. And I can imagine from like the flooding standpoint, if there's like a lot of rains or even if the hurricanes are coming in, if you don't have that barrier, you're just legitimately not going to have a wall basically to like protect yourself from the waves that are coming in from these hurricanes.
Absolutely. I mean, you might ask yourself, well, why did these corals disappear, right? Because that's not an easy or totally simple question. And, what other purposes do these animals in the ocean serve? And it's not only coral reefs, but Alta Seas is an organization out in California that's trying to replant the kelp forests because those also serve as a big barrier towards storm surge. Alta Seeds, which is a kind of a corollary to Alta Seas, is something that our company Aperture is sponsoring and helping to fund, which is through our organization, our nonprofit called Aperture Circle. But one of the big reasons why the reefs around Florida have been so decimated, and it's not just the rising temperature of the ocean. It's a contributing factor, right? It's the pH of the ocean is dropping, contributing factor. But in Florida specifically, man, there's a lot of development on land and all that water that used to go through the mangroves, that used to get filtered out, that's now hitting the reefs with all of the human activity and all of the development and all of the wastewater, right, that isn't properly treated before returning to the environment, or runoff from farming. All those nutrients in the water, it just totally creates algae blooms and destroys the coral's ability to do photosynthesis, and they basically die off.
Let's kind of revisit your startup story now. I want to talk a little bit about Ecotech. You touched upon it when you first opened the podcast, but let's kind of rewind back to what is Ecotech? What were you guys working on? And I think we have a clear picture of the coral and the reefs, which I know you're going to touch on a little bit. But let's jump into Ecotech.
Well, Ecotech was founded back in 2003. Two business partners, or actually two college buddies, and one was a mechanical engineer, one was a physics major, myself a material science engineer. And we were aquarists. And we decided one of my friends, Tim and Justin, they were building stuff back when they were in high school, equipment for their saltwater reef aquariums. And when I became roommates with Tim, our junior year of college, we had an aquarium in our apartment. And I came across in one of the classes I was in for engineering was this invitation to innovate and having this entrepreneurial desire, this kind of innate in me. I think these things kind of run in the family. We got a lot of entrepreneurs in the family, but I thought this is a really interesting opportunity. Maybe we could take what Tim and Justin were working on and then make a new product and take it to the next level. So we kind of were given this structure and a year to work on this. It was a lot of money at the time. It was $2,000 we got to use towards prototyping or whatever we wanted. And so, we designed a product that never made it to market, never really got produced, but it was an amazing learning experience. And it allowed us to continue to work on the product and the project and the company as we went into grad school at Lehigh University. Tim and I were there.
And what was that initial product? What did you guys come up with, and how did it roughly work?
Well, the first product was called a Kalkwasser reactor, which is a technology that existed at the time, but it was one that we built and manufactured, and we were going to add a pump so that when water inside of a saltwater reef aquarium evaporates, it becomes more salty. So you have to add fresh water. Now, other needs that corals have are calcium to do the reactions to actually deposit calcium carbonate and grow a coral skeleton. And alkalinity or base is important as well. So calcium carbonate dissolves, calcium hydroxide dissolves in fresh water. It doesn't dissolve directly into saline water. So we added calcium hydroxide powder to an acrylic reactor. That reactor had a magnetic stir bar that spun and mixed the solution up. And then we dosed that to replace the water in the aquarium that evaporated.
Really interesting. And then that would obviously help the coral grow more efficiently.
Ideally, yes.
Cool. And so what happened? You said the product didn't kind of see the day of light.
There wasn't really as much of a market as we probably originally thought. So, one thing that I've learned being an entrepreneur, and this was, 20 years ago now, is that you're going to fail. You're going to fail over and over again. And it's the resilience and your ability to get past those types of down situations or difficulties. So Tim and I got a chance to go to grad school at Lehigh. I was a research assistant at a PhD program, and he was a mechanical engineering teacher's assistant. So we got funded by the university to be at the university. And then that gave us the second job of being able to work on our project, work on the company. So we were friends, we worked together, we lived together. We were all the time, go, right? And so when we had the opportunity to think about, what's another product that we might want to build, we decided, maybe let's work on a pump and a battery backup that might work inside of the aquariums to simulate flow, like you have flow in the ocean, right? So my partner, or my buddy Justin, right? We came up with 3 ideas. One was a motor above the aquarium that kind of had a drive shaft that went under the water and maybe a little gear that turned at 90 degrees and with a prop on it, right? Let's push the water. One was just a power head that kind of sat with the motor in the water. And then Justin came up with this idea on a phone call, and he's like, why don't we take the motor and we'll put it on the outside of the glass, and we use magnets to transfer the torque through the glass and a propeller on the inside. And I remember on this call, I'm like, that'll never work. Justin flew out. He was in Oklahoma at the time. He flew out to Asa Packard Lab, the machine shop at Lehigh. We kind of got a key from the engineering professor. We could go in there anytime we wanted to, right? And this was before 3D printers really were available. So we're machining acrylic and PVC, and we, stuck a motor inside of a cylinder and then bought magnets and stuck them into a disc. And wouldn't you know, this thing actually transferred torque through the glass. And so we filed for a patent, and we ended up making a product out of this. And it was a unique proposition.
Really cool. And when you went to market with that one, how did that one work out?
So that was a kind of a long road between idea and hitting the market, right? There was a lot of grant applications, loan applications, different things that you had to do, everything before you manufacture. And Robbie, I don't have to explain it to you, right? there's the product development process. We need to figure out how to design it, how to build it, how to make it, how to drive it. This is a brushless DC motor, so we're driving circuitry. There's a lot of components that go into it. So we ended up getting grants and loan. We bootstrapped this thing without any outside investment that wasn't, let's call it foundations, and the city of Bethlehem, Lehigh University, Ben Franklin Technology Partners, which is in Pennsylvania, the Lemelson Foundation, which is a national entrepreneur foundation. I found every funding source we could possibly, think of, and helped us to get funding to build this thing. And it still wasn't enough, right? I had $25,000 of credit card debt. And I figured, I'll just go bankrupt, if this thing doesn't work out. I didn't know what that meant, but, it seemed like, why not, right? So once we realized, okay, we needed to get funding to make it, then we went out to a bank, and there's this thing called the SBA 7A program. And if you have a customer that's willing to buy from you, then they'll give you a loan. So we found a distributor called IceCap, and they agreed to buy 300 units if we could produce them. So we took that purchase order to the bank. The bank got financing guaranteed by the SBA, which is important for them because that means 80 to 90% of the loan, the federal government's going to pick up the tab if we default. So it de-risks it for the bank. And then we decided to, what we did is we started building them in our college apartment. Wait, that's not true. We tried to start building them at Lehigh, and then they're like, no, we're a nonprofit. You can't do that here. You might jeopardize. So, recruited our girlfriends, best buddies, bought a case of beer, and we're building these things in our college apartment. We got pallets of motors delivered, and this is not a commercial area. So, just making it happen. And so that's kind of the story of how we got that product to market. I mean, we took the first 10 units, let's call them beta prototypes, to a trade show, and they worked. And just the sheer fact that we had this innovative idea of the motor on the outside of the tank, it really struck a nerve. So people started buying them. Now, it doesn't mean they really worked that well because, there's a little thing that's called, you get a prototype and then you get the production parts. Well, the prototypes are never, or almost never, like the production parts.
100%. I can agree with you there. Yeah.
Yeah. So the first 300 units failed in the boxes on the way to the customer. Yeah. So challenge. Nothing's ever easy, right? So the injection molded part that separates the magnets wasn't packed as well in the mold, and the magnets collapsed in the box and pulled through that injection molded part. So we had to figure that out. And then it took us a good 5 years, I think, to really dial the product in. But it's to this day one of the company's best sellers.
Oh my gosh, that's awesome. So backtracking, you guys went out and got a bunch of grants and loans to kind of bootstrap about 25K or so.
Well, 25K was my credit card debt. I probably put it together about 120,000 between the grants and loans. And then we matched that with another 100K from the bank.
Got it. And fast forward, you guys had an injection molding problem where basically your first 300 units were basically wrecked because they didn't work. Took you the good part of 5 years after that to actually make something that was fully functional, working.
Well, let's say to solve all the problems, right? Because it was functional. They did work. They were, this is a new product, new technology. Entrepreneurs need to be gleefully ignorant of the challenges that lay ahead of them, or else they'll be way too depressed to continue on day to day. So this gleeful ignorance, allowed us to continue to just figure it out, right?
Yeah. And so then fast forwarding 5 years, you guys are commercially available in the market. It still to this day is the best-selling product from the company, like you mentioned.
Yeah, one of them, for sure.
What happened in between that 5 years to kind of where you are? What time period was that? Was it the 5 years in the future?
Well, I'd say, so we came out with, it was called the MP40. And that was, gosh, we introduced it at $349. And then later on, we came out with a smaller version, the MP10, which was kind of for smaller tanks. Then we had the bigger version, the MP60. And after we've built out the pump line, we decided to try our hand at LEDs. Now, this was kind of infantile at the time. Back in 2011, we started playing with this idea, and we had seen some products on the market. And when we decided to go full force into this, we built something called the Radion LED, which is a full spectrum light that met all the needs for corals for photosynthesis, right? So you're basically growing plants or growing algae inside of an animal underwater. So there's a lot of variables. And that product really hit the market at the right time. Our brand name was really credible. And so the Radion grew us from $6 million in revenue to $12 million in revenue basically overnight. So it doubled the size of the business. It basically almost coming out with that was a very difficult proposition. That we only were 12 people at the time, working in a 4,000 square foot building. And so figuring that out and building that, and then it being a success, not without its own problems, right, that we had to work through. But now the Radion is the most trusted and popular reef aquarium light on the market.
Wow, that's awesome. And so you guys had a handful of people, 4,000 square foot warehouse. You've just doubled your revenue from 6 million to 12 million. Really interesting. You've said this a few times. I want to kind of take a quick left turn or a sidebar and go to the specifics of what is coral, because I think a lot of people out there probably just think it's like a rock that grows, or it kind of looks like a rock, right? Like, so you said you guys can grow algae inside of a plant, right? Which is obviously what coral is. But can you, for the audience, just explain in lay people terms what is coral?
So I think it's bacteria. So zooxanthellae is a bacteria inside of a photosynthetic bacteria inside of the coral's tissue. Now, not all corals are photosynthetic, right? So just generic broad terms, you've got SPS coral, LPS coral, and soft coral. SPS is small polyp stony coral. LPS is large polyp stony coral. And soft coral would kind of be, it doesn't make the calcium carbonate reef, right? Now, corals propagate in different ways, but essentially they're a phylum of animals. They're a kingdom of animals. Maybe might not be biologists in the audience, maybe calling me out as a not correct taxonomy here. But what's interesting to me is that corals can propagate both sexually or asexually. Now, when we talked about the Coral Restoration Foundation, CRF, they were propagating corals asexually, right? But the more interesting thing was sexual reproduction of corals. So it was at this time that Jamie Craggs at the Horniman Institute in the UK was really making headway in getting these SPS corals to spawn. These are reef-generating corals, reef-creating corals to spawn in captivity. And corals are broadcast spawners, right? They live on little islands, like they're kind of, imagine little trees underwater that live on rocks, right? And they branch out, and they don't have lungs. So their fingers reach out up into the water column, and as water passes by them, it helps them to do their chemical reactions. They're absorbing CO2, or they're absorbing oxygen and generating oxygen in the photosynthetic process. But they can reproduce sexually through broadcast spawning. So what Jamie was instrumental in doing was figuring out what are the parameters that cause the corals to broadcast spawn. So Jamie Craggs at the Horniman, he takes our products, the Radion and the Vortec, and he, in his lab, creates and blocks out all of the other light inside of the aquarium. I mean, I'm talking about like every little seam of the aquarium is blacked out, total darkness. And his theory is if he can control the solar table, like the solar rise and set, sunrise and sunset times, simulate the solar insolation of the Earth traveling around the sun, simulate the lunar phases, so rise and set of the sun and the the lunar phases of the moon, and control the temperature of the water as it matches seasonal variations, that he could have and help corals to spawn in captivity the same time that they spawn in the wild. So he took corals from Singapore, put them into this setup, matched the Singapore parameters as best as he could. And lo and behold, as the corals in Singapore spawned, they were spawning inside of the aquariums in the UK. So why is this important? Well, asexual reproduction of corals is a labor-intensive, difficult process. Thousands and probably tens of thousands, if not more, hours of scuba diving is required to do coral propagation of that CRF method. But if you're able to cause sexual reproduction in corals, you're not only getting different biological diversity, but you can breed thousands, hundreds of thousands, millions of corals at the same time. And so when a coral spawns, the eggs and the sperm come together, they create these things called gametes, and they kind of swim through the water column and then they land on surfaces. And so if you throw a bunch of little ceramic discs in that aquarium, you're going to have thousands of little ceramic discs with thousands of baby corals that will grow into mature corals. And the technique of taking those corals, going out on a boat above a reef, and then throwing thousands of corals into a reef area, you get a lot higher chance. I mean, it's a numbers game. Statistically, you get a lot higher chance of having an impact and actually seeding a reef.
And from an efficiency and a velocity standpoint, compared to the old method, which was scuba diving and, putting the coral that way versus what Jamie Craig's figured out, how much more quicker is the timeline on doing it this new way versus the old way?
Well, I think they're techniques, right? Techniques to be implemented and trying to take action to help these coral reefs, these coral species to be protected and to repopulate. So there's a group at the Florida Aquarium that we've been working closely with that took Jamie's idea and then propagated it out to a large scale facility. So Carrie O'Neill at the Florida Aquarium has been working with us for a long time. Now they have a multi-pronged approach where they have 15 different species that they are doing long-term care for, but they're also doing cryopreservation of the species as kind of this genetic bank. And on top of that, in 2019, they founded a coral spawning laboratory. Now this thing's powered by radion lights, because we've been proven and shown that these lights are capable of bringing corals into the spawning state and sexually reproducing. And so it's that group that's really been one of the many groups worldwide, but the one that we've been working with most recently to really propagate in mass scale and really scale this thing up.
Wow, that is amazing. One question that actually hit on the other side of this is, how big is the problem from the actual coral side? Like, are we seeing, I've seen documentaries on like Netflix and whatnot, but like for the audience out there, you'd mentioned that DARPA is now looking at this. It's obviously a big issue for the state of Florida with more humans building things on coastlines, and the fact that, that's causing problems for the coral. How much and how quickly is our coral, not replenishing in the oceans right now? Like how big of a problem is this? Is kind of my question I'm trying to ask.
Ravi, it's a big problem. And, I've had eyes on it from my perspective inside of the industry. And, as a scuba diver myself and enjoying the reefs and being in this part of nature and it being such a beautiful place that I think we should preserve for our generations. But I've seen numbers and seen quoted that about 30% of the world's coral reefs are gone already, and that another 60% will die within the next 20 years. And it's a multi-variable problem. right? I think that you will see problems with runoff, which are very important. The rising temperatures of the ocean, corals do not do well as the ocean temperature rises. They can't pick up and walk further north or further south, depending on which hemisphere you're in. So the quick changes are very bad, right? Slow changes are easier to handle. And I think more importantly, a bigger problem, and one that really isn't talked about, is the acidification of the ocean. Once the pH of the ocean drops below 8, corals and other sessile invertebrates won't be able to do the chemical processes to create their calcium shells or calcium skeletons. And if they can't create their calcium skeleton, they can't grow, they can't thrive, they can't survive and propagate. And that leads us beyond just corals, because corals aren't the only animals in the ocean that use calcium from, and create calcium carbonate skeletons or shells. The exoskeletons of things like copepods, right? Things like shrimp, lobsters, all of those animals depend on the pH of the ocean. And if you think about it, right, all of the different phytoplankton, right, that are in the ocean, they depend upon this process to be able to exist, to grow. And the impact of the lowering of that calcium or the lowering of the pH in the ocean is going to impact the ability of these copepods and the phytoplankton to exist. And these are, when taken as a viewpoint of the entire biological system of the ocean, this is the foundation of the whole food chain. So there's a guy, I think his name is Howard Dryden, over at the GOES Foundation, which is global data collection. And they're looking for the ocean, and they're looking at the populations of this plankton level inside of the ocean. And they've seen that 30% of these populations have dropped and are gone 30 to 40%. And the impact of the acidification of the ocean and what is essentially a very linear drop is going to hit us in the next 10 to 20 years. And when these animals are no longer able to grow and the populations kind of collapse, well, that's going to have multiple layers of impact for us. One is going to be, well, the food chain of the ocean, right? They represent the basis of the food chain. So once they're gone, it's a cascading effect in the entire ocean, right? Not only that, but the phytoplankton, they travel from deep in the ocean during the night during the day, up to the surface level of the ocean, and they create currents actually inside of the ocean, one of the biggest generators of current, more than the lunar effect of the moon, more than the moon's gravity. So as they go up and go back down, they're creating these currents in the ocean. They also create this surface microlayer of different fatty acids that change how water evaporates from the surface of the ocean, which protects a lot of the weather patterns. So when those are no longer there, we're going to be subject to an entirely different climate interaction because of these animals, because the population will be gone. So I think we're looking at a multi-layered threat from an animal that I would say almost no one knows about.
I'm just going to re-say that back to you really quick. We're looking at a kind of multifaceted cascading problem with the root being around coral and these plankton, the phytoplankton. With the rising temperatures and the lowering pH, the acidification of the ocean, you end up having coral that's dying at a quicker rate, which is affecting our coastlines and being, just plainly a barrier between storm surges, the oceans hitting land. But then a really interesting point you just brought up right now was around this phytoplankton. One being that they are the base of food, the food pyramid in the ocean. And if fish larger and upscale from the food pyramid don't have this phytoplankton to eat, you end up with a cascading issue with just food production. We've had conversations on this podcast around food security, about how the oceans And fish sometimes are upwards of 60 to 80% of a country's diet at certain points in time. And if you're talking about this massive decrease in this population over the next 10 to 20 years, we have everything from a food security to a living security to just an actual climate and weather problem of our houses and our structures are not just like literally not built.
Well, and weather patterns that are going to influence farming on land, right? And farming is one of the biggest polluters of all the runoff from all the pesticides. And it's not just the pH, right? All the things that are coming into the ocean as well are creating this toxic soup, which everything lives, right? You know, a lot of your guests on your podcast talk about water and how water is the common element, the most common and important vitality thing for the earth, for life, for us, right? And we're mistreating it. And I can see that from this standpoint within the ocean. And I don't think enough, you're getting it, Ravi. You're connecting all the dots here, right? And when you connect all these dots, you're like, holy crap. And, you know, food security, we're going to see this happen in our lifetimes, is my guess, right? Now, it's really easy for me, and I get caught in this trap of this is really kind of depressing, you know, viewpoint. But one thing that I would say is that in some of how I approach life and some of the things the mindset that I want to think about this problem is one of abundance, right? One of ingenuity, right? One of this common thread of humanity. And I think people need to know about these things. And people need to understand the impact of the conveniences of our lives right now. We're living in the most prosperous time of humanity ever, right? And that has come at the cost of using a lot of energy in the form of carbon, right? Oil energy, gas energy. And this is life that has been passed away over millions and millions of years ago that turned carbon into other fuel sources that we're now releasing back into the environment, right? And so how do we think about and help spread the word about these problems so that people can take it seriously? Because without the proper information, without the proper perspective, right, we're unable to truly enact change. But how can you, Ravi, right? How can I, in our day-to-day lives, or whether it's small decisions that we're making or what we do with our lives, right? How do we help to solve the problem? Now, I think one thing is true. Technology is evolving at an incredibly rapid pace right now. I mean, you've seen it. AI most recently, holy mackerel, right? We're just seeing things move much more quickly. And we're bad predictors of the future individually. I think that there is opportunity for us to change course. There's opportunity of this multitude of futures in front of us. And there's some really bad ones, right? Where things go really wrong and really sideways, but it's not a binary either or, because there's some that aren't so bad, right? And how do people in the water industry, this old kind of group of utilities, and there's so many different people within the water space, right? Like I've been learning more and more, and there's so many different facets and governments and politics and avenues and technology. But how do we as a humanity, as technologists, as business people, create the opportunities to enact, spread the word and enact change and help people to understand the impact of the direction we're headed?
I think the first point definitely is around storytelling and getting the message out there. But if you were to enlist or instill the audience in 1, 2, 3 things they could do that they could take away from this episode, what would that be from a coral standpoint, a phytoplankton standpoint? You can pick your kind of topic, but like what's the puzzle piece there? What's the call to action? What can we do?
Well, it's a tough one, right? And I kind of, in preparation for your podcast, I had to do a lot of thinking about what I was going to say today. This is my first podcast, by the way. So, I think we're in this arms race of technology and the problems that the technology creates. And it's really hard to say what individuals can do. Like, okay, we can recycle, like try not to use plastics, don't use plastic straws. Like, there's these little things, but I don't know, I'm left feeling like a little vacant, like I'm not able to impact things as well. Where I think we should be focusing on as individuals, and where I think we should be focusing on as corporations and entrepreneurs and technologists, are what are we going to devote our lives to? What are we going to focus our lives on? Right? For at least many people in this world, have the stability, like Maslow's hierarchy, right? We've got a job, we have food for now, we've got, we've got all these basic needs met. And I believe once you get people out of the race to have more and more wealth and accumulate things to a certain level, I think people get trapped into that. And, by taking a step to imagine, well, what good can I do in my life, right? At the end of my life, like, what do I want to be known for doing? And like, how do I want to be remembered? Well, I want to contribute to some good things in my life. So what I'm focusing on, and I can maybe answer the question for you with my perspective, right? I want to learn about what's going on to the best that I can, educate myself about the impact that the world around me is experiencing from humanity. But how can we create a hybrid of economic benefit and technological innovation and solve hard problems, right? If I were to ask you, Ravi, like, what can we do today to reduce ocean acidification? Have you ever thought about it, right?
I would say no, not really, actually. There's outside of being on this podcast and interviewing a bunch of people, which is in a sense my exploration and my help to the public of better understanding water issues. The answer is no. Like, honestly, I don't think I have.
And I mean, getting ready for this, I asked myself the same thing.
Yeah.
I had a chat with ChatGPT about it too. So, but
And what did ChatGPT have to say?
Well, I asked ChatGPT what the possible solutions were, and what's already out there today, because there are people out there that think about these things.
Sure.
And MIT, in Stanford, they're working on carbon capture and sequestration. Nanoremediation, Rice University, they're working on little nanoparticles that can remediate certain elements in the ocean or change that. Autonomous water monitoring and drones, right? So one thing that Howard at the GOES Institute is doing, he's in a boat traveling around the world, sailing around the world, sampling, these little organisms from place to place. Well, how do we get 1,000 of those, right? How do we make this visible, right? And I have this kind of soft spot in my heart for these phytoplankton because I don't think it's well known. And I see Howard's plight and I'm like, how can I help this? Well, there's companies out there right now, Sail Drone, Liquid Robotics, they're out there sailing around the entire ocean, sampling different things. Well, why don't we just build an army of sailbot drones sampling these types of parameters to make it more public so that we understand? More data equals better choices, better solutions, better direction that we can head. But we got to make it visible.
We're running close to time here, Patrick. I have one question that I ask everybody at the end of the podcast. And it's, do you have a book, a TV show, or a movie that has given you the overview effect, change your view on how you view the world or the world of water?
So one that comes to mind is The Rational Optimist by Matt Ridley. And this book kind of gives you some really interesting context of our place in history over time and our prosperous situation that we find ourselves in. I think to some degree at the cost of some of the environmental things that we were discussing earlier. But in the book, Matt really lays out an optimistic view of the future with innovation as a key driver of a lot of the development that's happening. And that book really struck a chord with me. And I think in the context of this conversation gives a layer of optimism of we can work to make things better, which I think is really needed.
It's awesome. Yeah, I've had this thought from a few of the guests now where the problems are so large, especially in water and in climate, that we end up in this doomsday or very pessimistic scenario. And it's funny, whenever I ask this question, there's always a book or something that has this light at the end of the tunnel, or at least an optimistic view to think about the future such that we can then implement technology or policy or whatever that might be to actually get us to the end goal. Awesome. Patrick, thank you so much for joining us today on the pod.
Thank you for having me.
And for those of you out there, you can find Liquid Assets wherever you listen to your podcasts, be that on Apple, on Google. I think Google is actually deprecating their podcast app now, so I think it's YouTube. But anyways, just go to liquidassets.cc and you can subscribe there. Patrick, thanks again for joining us.